Welcome to page 3 of 1.5, and here's a discussion on domains. This, as I've mentioned on the previous pages, ends up causing us some challenges, probably more so than most of the just straight algebraic process. So determine the domains of A, F. Well, for A, I know that square roots present problems. So x plus 3 better be at least 0. So x has to be greater than or equal to -3, which is perfectly fine for the domain. If we're doing that in interval notation, we'll go ahead and say the domain is -3, and that's okay, to infinity. For B, the domain of G, hey, x can be anything here. I can start with anything I want here for x because I can divide any kind of number by 2, so that is all real numbers. And now for C, f of g, I need to find f of g of x. So f of x on 2 is square root of x on 2 plus 3. That is f of g of x. So now, for the domain for it, -3 isn't really my box anymore. I want to know, I know this, x on 2 plus 3 better be at least 0. So x better be at least subtract 3, divide 2. There's my domain for C. That, of course, is -3/2 is okay to infinity. Now, the answer key, I believe, will probably have this, but again, that interval notation is widely used in this book as we move on, and very widely used in calculus. So we want to get comfortable with that. All right, 48. Fourth root of x. That is, by the way, the fourth. X to the 1/4 is the fourth root of x. So for A, the domain, I can't, if this was third root, fifth root, seventh root, ninth root, 127th root, no problem. But I can't take even roots of negative, so x has to be at least 0. Interval notation, 0's okay, and up through infinity. For B, I can take any number I want to the 4th, all reals. For C, I want f of g of x as domain, so that's f of x to the 4th, which is the 4th root of x to the 4th, and you want to talk about sneaky right here. The 4th root of x to the 4th, we would love to say it is x. But x might be a negative number. And if x is a negative number, this becomes a negative number to the 4th power becomes a positive number. 4th root of a positive is positive. So this is the positive version of x. Now, if you came up with x for this answer, I would be pretty good for f of g of x equals x, but it really doesn't equal x. It really equals the positive version of that. It really should be absolute value of x. Now, let's follow the path. I'm going to take a value, I'm going to put it into the 4th, and I can put any number I want into the 4th, and any number I put into the 4th becomes a positive, and or 0, and positive or 0 are good here. Our domain is actually all real numbers, because we go through G first, and G is going to fix our problem. So that is more sneakiness as promised. We got some challenges there. A lot of it's straightforward, but sometimes we got some little challenges. Okay. So pay special attention to the back of the book solutions. You may have done everything right, what seems to be algebraically right here, and the back of the answer might be surprising. When that happens, I'd like you first to go back and try to figure out why are we getting that, and then don't hesitate at all to ask questions. We're going to have questions on that material. So A, the domain of f, hey, I can't divide by 0. X may not equal 0. B. The domain of G, well, if x is 0, we're dividing by 0 again. X may not be 0. C. F of G of x. F is a factory that takes things and puts them underneath 1. So that becomes 1 on 2x, which is 1 times 2x on 1, which is 2x. And here's more sneakiness here. Remember, for f of g of x, we have to take x, we have to run it through g, and then that goes into f, factory f here, and comes out. So it has to be able to pass through g. If I only look at this, the domain looks like it's all real numbers. But we have to get through g. And g will not accept a 0 in the denominator. So x may not equal 0. Now, I have to put non-zero into f, but any other than 0, any other value for x, g can't be 0, so I can never put 0 into x and divide by. So it doesn't look like 0 is a problem, but I promise you 0 is a problem. And this is a good time for me to illustrate that on a calculator. So I'm going to go into y equals, I'm going to clear this, and I'm going to go, f on g is this thing. I'm going to write it just like this. Let's go fraction. I'm going to go fraction 1 over fraction 1 divided by 2x. Nope. Let's delete that because I did a fraction again. So delete 1 divided by 2x. So just trying to illustrate this. So if I go to Zoom 6, Zoom Standard, this graph looks like the line y equals 2x. I think you can see that. It looks like we have a slope of 2. It looks like this line. And if I go, let's just go second calc value, and I put in 1 here, we see it's at 2. I put in 2 here, we see it's at 4. I put in 0 here, and we see, wow, it looks like 0 is at 0, but 0 does not exist. If I put in 0.001, I'm at 0.002, or 1 on 500. Interesting that it went to a fraction like that. But if I put in 0 again, it does not exist. So once again, a little sneakiness. 52a, f of g of x is f of x minus 5, and f is a factory that puts things in the denominator inside square roots. So we have the danger of dividing by 0. I can take the square root of any number I want, but I can't have 0 in a denominator. Therefore, x may not be 5. Oh, that's not really what I was charged with first. That's actually part C. I got so caught up in that discussion on number 50. That's actually C. A, the domain of F, so here's part A, there's part C. If I had pride, I'd go back and restart this video, but that's okay. You guys understand. If I put 0 in here, I've got problems. X may not be 0. And B, X can be anything for G, all real numbers. I can subtract 5 from any number I want. I just can't put 0 in denominators, but I can have a function be 0. All right, let's do 54 in the right order here. For A, the domain of F, x squared minus 1 may not be 1. Therefore, x squared minus 1 may not be 0. Therefore, x squared may not be 1. How do we get rid of a squared? And if you just said square root, well, you're partly right. With a plus or minus square root of 1. which is, of course, 1. B, the domain of G, I can add 1 to any number I want. So all reals. For f of G, that is f of x plus 1, f is a factor that takes things, puts them right there, squares them, subtracts 1 from them, and puts them underneath 3. So I get 3 times x plus 1 squared minus 1. F takes things, no matter how ugly they are, puts them right there, squares them, subtracts 1, puts them under 3. Well, I guess we're going to simplify that. So I get 3 on, I get x squared when I FOIL, plus an x plus 2x. I get a 1 times 1, 1, but minus 1, I get this. So my domain for this, x squared plus 2x, may not equal 0 if I factor. X times x plus 2 may not equal 0. X may not equal 0 or negative 2. Watch this. Why can't I put 0 here? Well, if I put in 0 here, I get into G, I get 1. And then if I turn around and put 1 into this function, I've got problems. If I put in negative 2 in here, I get negative 1. If I put negative 1 in here, I get negative 1 squared, positive 1 minus 1. I get problems. So in front of my little sentry guard, here's G. I take G of x, put it into F. If a 0 or a negative 2 comes in here, I don't have problems in G, but I have problems down the road with the result of those in F. I hope that makes sense. That's a 12-minute video, and probably looking about that for the homework. You got some. If you have challenges, of course, I'd like you to double check it, but do not hesitate whatsoever to let me help.